Hello and welcome to another one of Dee's ADD videos. Before we get started on the example video, I want to make sure we refresh our concept. The washer method is what we're going to be talking about today in our example. And when we rotate a 2D object around an axis, then there is going to be a 3D object. If the object has a hole, that's the key to doing the washer method. Here's the formula. The formula is going to be pi from alpha to beta integral of f of x squared minus g of x squared, where f of x is the top function and g of x is the bottom function. All right. Initially, we'll graph them to determine that, and if we're dealing with y-axis problems, then we'll have the leftmost function and the rightmost function there. But for now, we're just going to do a basic example. So let's see it in action. So the problem itself is going to be a rotation of a shape formed by these two y graphs. You should know this is a straight line and this is a parabola. Okay, so what does it look like? Would be your first question, or should be your first question. So two-dimensionally, if we were looking at those two shapes, we would have y equals 2x in red, a linear function going through the origin, and y equals x squared, which is a parabola that you've dealt with time and time again. So the region of interest is what we're looking for in green. You're going to rotate about the x-axis, and when you rotate about the x-axis, you'll get something that looks like this, and then it'll keep going, and then after it keeps going one more time, you'll get that basic pattern there. Okay, and when you do so, you're going to end up with a 3D object. So let's take a closer look and see what that 3D object might look like. So three-dimensionally, that would look something like this. So if we were rotating about the x-axis like that, we would get that sort of three-dimensional shape. Okay, and you can hopefully see graphically what's going on about the outer and the inner layers. Hopefully you can see that the outer layer is formed by the top function here. Color it in red. If you remember, our 2x was in red, so let's try to keep that theme going. And three-dimensionally, you can see that that forms the outer. This is when we're talking two-dimension. It's the top. But 3D, you can see that it's the outermost boundary of the region. Okay? So in your formula, that would be your f of x. Now when we're looking inside the region, you should be able to see that the region has a gap in it. So the inner boundary, the reason we have a hole is because of this function right here, which was part of your x squared. So y equals x squared is bottom 2D and inner function when we look at it 3D. So hence it's your g of x. Okay? And that's the hardest part usually for most people, is assigning which one's your g of x and which one's your f of x. So now it's just a matter of plugging and chugging into your formula. Alright, so graphically we were able to determine that our f of x, the top function, was 2x, and we got to square it, and our bottom function was x squared. We didn't figure out our intersection points, so let's do that now. And the way we figure out the intersection points is we just set them equal to each other and solve. So if we were to do that, we would get 2x equals x squared, and we would bring it all to one side, then try to solve for x. So we factor out the common x, we get the endpoints. The lowest one's going to be your alpha, and your highest one's going to be your beta. Let's say you don't remember what these things look like and you can't graph them. What you could do is you could plug in a value in between 0 and 2 into both functions and see which one gives you the largest. What that tells me is that in between those two numbers of 0 and 2, I know that that is on top. So that would be my outer function. So I really didn't even need to graph it. Okay, but I just wanted you to visualize what was going on so that you could determine that 2x comes first and x squared comes second. Okay, once you got that part down, then it's just a matter of integrating and plugging and chugging. So when we're doing that, we're going to be squaring that first. Okay, so when I integrate that, I'm going to add 1 to the exponent and divide by the same thing, the power rule. And since they're added, subtracted, you can do them separately. You just do the top bound plugged in everywhere you see an x, minus the bottom bound plugged in everywhere you see an x. Luckily the bottom bound is a 0, so it's going to be minus 0. When I plug in, I'm going to get... I'm just doing this for your benefit. You should be able to see that all that goes to 0. So that's basically it for the washer method. The key is when we rotated it three-dimensionally, we got a hole in the middle. Now, without knowing these graphs somewhat, you're going to have a tough time determining whether it's washer method or disk method or shell method. So make sure you practice your graphing, but if you can visualize roughly what's going on in your head, combined with what's going on over here, you should be able to determine what's on top, the outer function, and what's on bottom, the inner function. Okay? Hope that's clarified things enough for you to practice some problems on your own. The key to all of this, any of this, is to practice as much as possible, and then it'll become second nature. Thank you and have a nice day.